Okay, so we know that we need to know all this old stuff before we start. We have to know our trig functions. We have to know where they're positive and negative. And we have to know when we go this way, we have positive angles. When we go this way, there's negative angles. If we want to put them all in, this would be pi over 4, right? This one would be negative. Well, I'll start with pi over 6. Pi over 6, right? Negative. Then we'd have negative pi over 4. Then we'd have negative pi over 3, right? So everybody remembers that when you count, backwards is a negative angle versus positive. Okay, that's just your little trip down memory lane. Now let's look at what we're talking about. You're used to graphing in what's called rectangular mode. You've never called it rectangular mode because that's all you knew, so it was just graphing. But when you have a point x, y, like 3, 4, and you graph it, that's a rectangular mode. What we're going to look at today are polar coordinates. Polar is we use the radius length and the angle. So you think about a center as a pole, and it's going to make a circle graph instead of square. This is kind of a little mini brain. This is stuff that in the perfect world you would commit to memory and memorize. We know this year you have notes. So this is the important part. If you know all of this, we've got smooth sailing through our new stuff. So let's figure all of this out. Now this is X, this is Y, this is R, right? It's a triangle. This is a right triangle, right? So what would the ratio be for cosine? Cosine is adjacent over hypotenuse, right? So for this triangle, what would cosine of theta be? Oh, this is adjacent. This is opposite. And this is hypotenuse, right? So what would our ratio for cosine be? Adjacent over hypotenuse, x over r. What would our ratio for sine be? Opposite over hypotenuse, so that's y over r. And what would tangent be? The ratio for tangent is opposite over adjacent, so that's y over x. Nothing new, you know that. You know that. So now my question, if you had this equation, cosine of theta equals x over r, could you get the x by itself? What would you do to get x by itself? Well, you'd multiply both sides by r, right? So what is x? X is r cosine theta, right? All I did was multiply both sides by r, and I have r cosine theta equals x. Then what's y going to be? Y is going to be r sine theta, right? Are you with me? Is that making sense? And what about r squared? When you have a right triangle, like this one right here, it forms a right triangle. What is the rule? What's that theorem you have to find one of the sides? Pythagorean Theorem. A squared plus b squared is c squared. So in this case, we have what? X squared plus y squared equals r squared, right? That's just the Pythagorean theorem, but we're using x, y, and r instead of a, b, c. Because x is this direction, we know that's an x value. We know this is a y value. And this hypotenuse is r for radius because we're going to go all the way around and have a circle. So let me ask you this. If r squared is x squared plus y squared, can you find what r is? What's r? What would you do to get r by itself, or unsquared, if you will? What do you do to both sides of the equation? Well, we square root it, right? And the square root of r squared is r, and it equals. Now we cannot make the mistake of writing x plus y. You can't take the square root of each one because this is x squared plus y squared under the radical, right? Okay. And lastly, how do you find an angle if you know the sides of a triangle? If we know y and x, can we find the angle? Yes, which trig function is that? Tangent, right? So theta equals inverse tangent of y over x. Your calculator, how you type that in is what? Second tan y over x. You won't need your calculator today because I'm going to give you ones that you have memorized off of your chart. So you won't need a calculator. Your calculator won't be good because I want you to use a radical answer and your calculator is going to give you decimals. So if you can look at this and you have your brain with our old stuff, smooth sailing. Easy, easy, right? So let's look at this. Convert the following polar point into rectangular coordinates. I should have the word to right there, to rectangular coordinates. So let's make a little note here. Polar is r theta. So when you get a polar coordinate, you need to know this is r, this is theta. If you're given rectangular, which is what you're used to, that's an x and a y. And today we need to be bilingual, able to go from polar to rectangle, rectangular to polar. I think I said rectangle instead of rectangular. So if this is polar, that means this is r, this is theta. True? Now from our new little mini brain up there, how can you go from r to x and y? What formula? How do you figure out what x is going to be? It's written right here. What does it say x is? R cosine theta. So that's what? 2 cosine 5 pi over 6. Very easy, right? What does this remind you of? Does it look like vectors where we had magnitude cosine theta? And to get this is going to be our x coordinate. We also need to find our y coordinate. And what is y going to be? It's right up here, r sine theta. So 2 sine 5 pi over 6. Now we have to go back to your circle. We don't want a calculator because it's going to give us a decimal if it's a radical. And y'all need to remember what 5 pi over 6 is. So we're going to fix this. And that's going to be 2 times, what's cosine of 5 pi over 6? Well, 5 pi over 6, the number for cosine is the square root of 3 over 2, right? Because it's a 6. And 5 pi over 6 is up here in that quadrant. 6 over 6 would be all the way here. So if the top is smaller than the bottom, we're in the top. So what sign does cosine have up there? It's negative, right? So that's negative square root of 3 over 2. That part you're going to have to know. Comma, 2 times, what is sine of 5 pi over 6? Sine of a 30-degree angle is 1/2. And up here, sine is positive. So that's 1/2, right? So let's make a note that this part turned into that, right? You want to look at this later and know where stuff came from. And this part is where we got that, and the 2 was there. So now we'll multiply these. We practice multiplying fractions. What happens with 2 times the square root of 3 over 2? The 2's cancel, and I have negative square root of 3. Here the 2's cancel, and I have 1. That's my rectangular point. There we are. And I want you to notice something else. Where these 2 points are in the same location on a graph. So if I were, I'm just going to get a piece of scrap paper. If I were to graph 5 pi over 6, you know that that's right along this line, and 2 would be about there. And if I were to graph negative square root of 3 and up 1, it would be there. So your points mathematically will be in the same spot. Does that make sense? It's just how we're naming them. We're naming this one with a rotation and a radius, and we're naming this one with its integer or decimal or square root. Okay, now we got to go backwards the other way. So convert the following rectangular to polar. So this is XY because it's rectangular. I want you to really pay attention. I think right now it's better if you write your X and Y down so you're remembering what you're looking at. Since they said it's rectangular, it's X and Y. And you want it to be what? You want our theta, right? So look up at our little mini brain. And if I have X and Y, how do I get an R? What is R equal to? You have it right up there, don't you? So we're going to say R equals X squared plus Y squared. What's 3 squared? What's negative 3 squared? Make sure that you don't type negative 3 squared into your calculator. If you do it without parentheses, it'll tell you negative. Don't worry about the negative sign if you're going to square that number. It's always going to be positive, right? So what is that? Square root of 18. I can't leave that. What perfect square can you pull out of 18? 9, right? That's 9 times 2. So it's going to, square root of 9 is 3. So there's our R value. Now we need to find our theta. Do you have directions right here on how to find theta? Yes, how do we find theta? Inverse tangent, right? So theta equals tangent -1 of -3 over 3, which is really what? What is -3 over 3? Yeah, right, that's really this. And you know where tangent is -1. We got to think now. First of all, which 2 quadrants is tangent negative in? You're going to have to figure out which one it is, right? Now tell me before we do any work, which quadrant would the point 3, -3 be in? Well, that'd be 3, -3. So it would be in the 4th quadrant, correct? Okay, so we're only looking for this one. We don't need that one because we have to be in the same quadrant as our rectangular point. So what family is tangent to 1 on? Pi over 4, right? That's where tangent is 1. We want it to be negative, so that tells us the quadrant. What's the name of the angle that's in the pi over 4 family down here in the 4th quadrant? 7 pi over 4, right? That goes back to your old brain that we made, so pull that out. So our answer for this is going to be 3 square roots of 2, 7 pi over 4. And I write too big. Is that okay? Could you do that now that you have a system for each one? I think your first plan of attack on these, you want these to be easy. So I would determine when I was given a point, whether it was r theta or xy. And then all you have to do is look up here. How do you turn x's and y's into r's and thetas? If you're given radius and theta, you're like, okay, how do I turn that into an x and a y? It's the same process every time. Not bad, right? It's not bad. All right. Number 2 objectives. And I'm going to draw a line across here because yesterday I looked up at that problem and wrote the wrong thing down because my eyes, there we go. How do we graph these? It's very easy to graph. All you do is figure out where you want to land and then count that far. It's that easy. So I'm going to start with a purple one. I'm going to color code 9. So later, if I'm looking at this, I know where the point came from. So where is 5 pi over 3? It's right there. True. And you're going to start at center and walk how many rings out? 4. It's that easy. So I'm going to say 1, 2, 3, 4. There I am. Nice, right? All right, let's look at B. For B, what's my degree? Now it's telling you that these are polar, so you know that this is not the 0.30. You know it's 3 towards 0 degrees, which ends up in the same spot. There's 0 degrees. And how far am I going to go there? 3. 1, 2, 3. Not bad, right? These aren't bad. Now, what about C? How do you think that's different? What do you think the -2 means? Give me a guess. If you had to guess to survive and get out of my class, what would you do? Yeah, what does negative mean on a graph? No, but that's a good guess. Think about a negative. When I take a graph, x squared, and I put a negative in front, what does it do to it? What does it do to a graph when you put a negative in front? Flips it over, right? Yes. So you're going to walk backwards, if you will. So I'm going to find 5 pi over 4. It's right there. But now the -2 says I'm supposed to walk backwards. So instead of going towards 5 pi over 4, I'm going to walk away. So I'm going to be on the opposite side of that line. Easy, right? You just have to know to do that. Are we okay so far? I think these are kind of fun. Let's look at D. All right. This says negative pi over 2. So where is negative pi over 2? Where is it? Be right here. Y'all all notice, right, that if you need a negative angle, it's just reflected from its positive. So if you want negative pi over 2, you just go to pi over 2 and negatives down here. Just like if I wanted negative 3 pi over 4, I'd just find 3 pi over 4 and I'd flip down to here. Y'all realize that, right? The top and bottom, it's like a mirror. Okay. So there's my negative pi over 2. So this is where I'm headed. And how far am I going to walk in that direction? 1. So I'm coming down to 1. Do those make sense? Are those okay? Easy? The only thing you have to remember is when you have a negative here, you're walking away from where you think you're supposed to go. This gets a little tricky now. What we're going to do you remember coterminal points? Where you could go this way and I could still land here. If I wanted to be on that purple dot, I could start here and go all the way around, or I could start here and just walk that far. Well, we're going to name coterminal points for A, B, C, and D. So let's look at what we have. Letter A is positive and positive, right? True, they're both positive. So I'm going to write that down. I'm going to write down what I already know on all of these. Now, letter B. Letter B is still positive, positive, right? So I'm going to write down what they gave us. Now, letter C, what did they give me? A negative and a positive, right? So they gave me a negative and a positive. So the given is actually this one. You see why? Negative, positive, negative, positive. This one, they gave me positive, negative. Which one is that? That's this one, right? So I'm going to put, if I write them down ahead of time, it keeps me from looking up at the wrong problem, which I'm good at doing. So what they're asking you to do here is name other ways to get to that same dot, like a second set of directions, if you will. So positive, negative. Now, I want you to look at these. Whether it's positive or negative, the 4 never changes its number, right? Because that's how far you have to walk out. So on all of these, you're just going to write down. Now that says negative, so I want -4. That says negative, so I want -4. What I really have to figure out is what am I going to call the angle to get to the same spot? So now, if I want to be right here, right, I still have to get to this purple dot, but I want my negative to be named, I want my angle to be named as a negative number. What would I call this if I started here and I walked that far? What would be the name of this angle? Well, you could just look up here and see what it would be. What would it be called? Be pi over 3, but it would be what? Negative. That goes back to information we've been practicing. Now, if this is -4, and I still want to land here, the negative means I'm walking backwards from the named angle. So instead of naming this angle, what angle am I going to name? I need to say that I'm going there, don't I? I need to say that I'm going to land on this 3 because I've got a -4, which tells me to walk away. So what's the positive name for this angle? 2 pi over 3. And now it wants the negative. So what's the negative name for this angle? What's the easy way to find the negative name for this angle? Just look at its reflection. What's the negative name? What is it? -4 pi over 3. That makes sense. We're going to practice the 4 of these together. I know this is a little weird coming up with all these different names. Just remember, when it's negative, when your R is negative, you've got to plan to go to the angle opposite of where you want to go because that negative tells you to walk backwards. Okay, 3, 0. Now remember, your radius never changes its name, just its sign. So if this says positive, we're still +3. Now we want -3 and -3. What we have to do is rename the angle. So if I'm supposed to start at 0, right? Because I want to land here where this green dot is. What's another name for 0 if I'm going backwards? Well, I start here and I go all the way around. So what's the name of this spot? -2 pi, right? Now, if this 3 is negative, I still want to land on the green dot, but the negative means I need to be over here because I'm going to walk backwards from pi, correct? So what would the positive name of this angle be? Pi, right? And what would the negative name of this spot, this location be? -pi, right? Because if I start here and I go this way to be negative, that's called -pi. All right, now we got this pink dot. This is where I need to get, but I want different sets of directions. The original point given to us was 5 pi over 4 because it was negative and I walked backwards, right? So how could I give someone directions to land here and have, now the 2, the radius never changes, right? So I want 2, 2, -2, -2. And why am I picking all these numbers? Because that's what they told me they wanted me to do, to find a positive way. So where do I ultimately want to land? Let me erase these. That's why I'm writing in pencil. So for this particular one, I want to be headed this way because that's the pink dot. So what would the name of that angle be? A positive angle. That would just be pi over 4. Now they want me to call it a negative angle. That means I'm going to start here and go all the way around the circle. So what's the negative name for that angle? All you have to do is look at its reflection. What's the negative name? -7 pi over 4. Not too bad, right? Now, what's the negative name? If this is negative, if I want a -2 radius, that means I have to look on the opposite side. So I need to land right here. What's the negative name for that angle? Just look up at its buddy. What's the negative name? If I want to land here, but I'm going backwards, what's the negative name of that? -3 pi over 4. Right? That makes sense? Not too bad, a little weird. So the first thing I'm going to do is fill in my radius. Right? They're asking me for all ways to say it. So my goal is to tell other ways to land on this turquoise dot. So what would the positive angle be? Meaning I start at 0 and I go all the way around to this way. What's the name of this location? 3 pi over 2, right? Now, again, let me erase my pencil mark so I can re-explain with a new person. Okay, so I need to be here. I need to land right there. So if this is a -1, that means I'm looking at this location, right? Because I'm going to walk backwards. So backwards would be this way. So what's the positive name of that angle? Pi over 2. What's the negative name of this same angle if I start here and go there? What's the negative name of that? You can look down here and see. Okay, so all 4 of these names land you in the same dot, right? Different ways to think about it. I promise not to give you a million of those on the test. Those are really upper level, really got to be thinking about it problems. Okay, I'll come back to them if you want more help. Okay, I'm giving you a mini test right now. Are you ready? Are you ready? This is the same brain I put on the other side. I wrote it down again for you to try to go through and write it. So take a second, don't peek, and see if you can look at the triangle and fill this stuff out. Just try. We'll put it up there if you need it, no worries. I'm going to hide it and I'm going to write them down. I want you to take a second and try to do those. If you're looking at the triangle, you should be able to figure them out, right? So take a second and do that. And the reason I wrote them on the top of the second page is I can't stand to flip back and forth. So I want that information right there because that information guides me through the entire lesson. So just take a second, see if you can figure it out. I wrote it down so you can look up here if you need to and you can check your own work. But if I were a student, I would always write that down. Like if I had to take a test in non-COVID times, I would write that down before I started if I didn't have access to my notes. Right? Remember, this all comes from looking at that triangle. So think about what you're doing. We've got trig ratios, opposite over hypotenuse, all of those SOHCAHTOA, and then we've got a squared plus b squared is c squared, right? So this is nothing too scary. All right. So now what we want to learn how to do, we looked at graphing points. What about equations? Okay. So this says convert the following equations to polar form. What does that mean? I need better words. That's too scary. What that means, get rid of x and y. It means when you're going to polar, you no longer have x and y, you want r. Right? On the flip side, What do you think it means down here where it says convert the following equations to rectangular? What do you think we're going to get rid of here? Get rid of r. And theta, if there is one. We don't want r's and thetas anymore. So this is the English way of what you want to tell your brain to do. You may forget what it means. Convert to polar. What does that mean? It means get rid of x and y. It's very easy to do that because you can look at this x and you can look up here and what is x? What can you substitute in for x? What does it say x equals? R cosine theta. Now, wasn't that easy? Because right here, there's x. There's x. That's all there is to it. Now, if you're left with an equation like this, you should try to get r by itself. What could we do to this equation to get r by itself? Divide by cosine. That's okay. It's all right. It's a decent answer. Can you think of a better answer? What's not beautiful and perfect about this? Do we leave trig functions in the denominator? No. We'd really rather have cosine up out of the denominator. So we need, instead of writing cosine, we'll write its reciprocal because a reciprocal flips it over. So what's the reciprocal of cosine? What can we write instead of cosine in the bottom? Secant, right? Because cosine is 1 over secant. So secant is 1 over cosine. And this is really 1 over cosine times 6. So this is wonderful. If I were grading a test on pencil and paper, I would take this, but this is superb. We'll have to look at like a delta math or something. We're going to do our homework on paper for this one. If you work in a program, they're probably going to look for that. Okay. X squared plus y squared. What do you recommend? What is x squared plus y squared? Do you see a sub up there? What is x squared plus y squared? R squared. Wasn't that easy? You know it was. And when you have an equation and it's r squared, what does it really turn into? What's the square root of r squared? We don't really need to write the plus or minus with this because that's the radius. And y'all, let's go back to geometry for a second. When you see an equation x squared plus y squared equals 25, what is that? Is it a parabola? Is it a line? What is that? It's a circle, right? With a center at 0, 0. So if you want to pull yourself back to geometry, because there's no number with x or y, the center's at 0, 0, the radius is 5. We have a circle. So we're not taking away what you used to know. We're not taking any of that away. It's the same thing. All right, this one I know you're going to have without my help. So y equals 7. Do you have another name for y? Right up here, what is y called? R sine theta. Can you get the r by itself? And what am I going to say about this answer? It's okay. It's not beautiful. What's the beautiful answer? The reciprocal of sine. Wonderful. This is what we want, right? We don't leave trig functions in the denominator. We are professionals. This isn't too bad, is it? If you have your examples to look at, you could do this. All right. Now we're going to get rid of r and theta. We're going to follow the same technique. We're going to look up at our brain and see who we can sub. It's all about substituting. So what's another name for r sine theta? Why? Are you telling me we're done already with that? Yes. Now I'm going to go over here and do C first because B takes me a lot of room. So I want to do C first. So what do we know when we know an angle? What does an angle equal to? What does theta equal? What does theta equal, guys? It's tangent, right? So kind of you could think about it as taking tangent of both sides. So tangent theta equals what? Tangent of 2 pi over 3, right? And what is tangent? I'm going to write tan both sides. Okay. Do you have a substitute for tangent? Look up here. What's tangent? Okay. Now, what is tangent of 2 pi over 3? This you have to get from your brain. You have to know that. What is tangent of 2 pi over 3? Well, where is 2 pi over 3? It's up there. So we know tangent's negative. It's a 60-degree angle, and tangent of 60 degrees is what? Square root of 3. Did you really believe me when I told you that those charts would never go away? Now, in a rectangular system, which variable do you usually get by itself? Equations are usually what? Y equals. So can we get, we don't want to leave a variable in the bottom. So we would say what? Right? We'd multiply both sides by x. Are we good with that so far? Not bad. Do you feel like if you have this to look at, you're okay? Yeah, if you have that to look at, you're okay. And as a kid, I would always just, if I had to take a test, I'd just write this triangle, and then I'd say, okay, I need SOHCAHTOA, I need my 3 ratios, and then I need to look at the Pythagorean Theorem. That's all it is, right? All right, let's look at this last one. What are you going to do? Tell me what you think you'd like to do with that. I want you to look at this and look up here and tell me what you want to do. What about this guy? Who is he? Who is he? Who is 2 cosine theta? Can you get him from up here? Sort of. You'd like it to be an x, wouldn't you? But there's a problem. This has a number in cosine theta, and it's supposed to have the letter r. You don't have an r. What can you do? What can you do? You have to get an r in there. How can you get an r in there? Can you multiply by r? Can you just pick up and multiply by something? Sure. As long as you what? You can do anything you want to an equation as long as you do it to what? Both sides. So I'm going to have to multiply this side by r because I need it to match up with that. But if I do that side by r, I got to do that side by r. But that's okay because I'm going to get r squared, and I kind of like r squared because r squared is up here on my list. So what do we have now? It's like magic. I want y'all to listen to that because that's something that we don't always remember. When you have an equation, if you need something on one side, if you've got an equal sign, you can add it or subtract it or multiply it on one side as long as you do it to the other, because that keeps it balanced, right? When you have an equation, you have something on each side. There's an equal sign, means they're equal. So as long as you put something on one side, as long as you put it on the other side, it remains balanced, right? Just like a scale. Okay. Now, what do you think we do with that? We're trying to get rid of r's and thetas. Can you replace r squared with something? Yes, you can. Now, can you replace this with something, this part? Who is that guy? Look up at your brain. Who is that? It's x. Have we succeeded? Is r and is theta gone? Are they both gone? Yes. And this answer is okay. That's all right. It's okay. Is it perfect and beautiful? No. Can we make it perfect and beautiful because we're professionals? First of all, go back to geometry. I'm going to send you to geometry and then on to algebra 1. What is this figure? Is it a parabola, a square, a rectangle, triangle? What is it? X is squared and y is squared, and they both have the number 1 in front of them. What are they? They both have the same coefficient in front. It's a 1. So what is it? It's a circle. You have to recognize if you have x squared plus y squared and the numbers in front of the x and y are the same, it's a circle. What's the formula for a circle? Let's go back to memory lane. Got to go to geometry. A circle is x squared plus y squared equals r squared. That's a circle. This is a circle at 0, 0, right? Now I can move it what did I do? That's a K. This is a circle not centered at 0, 0. It is at HK. Do you remember that? So this is a circle. What did I do? That should say y minus k. All right. I'm getting excited because we're going back into geometry and I'm writing crazy things down. There we go. Y minus k. So the x and y are still there. They're still squared, but we have a number that moves them. Now let's go back here. Do you think that that 2x should be over there on the right side, or do you think it should be sitting by its buddy x squared? What do you think? Think about a circle. I think this 2x should be over by its buddy, so I'm going to subtract it. I have to move that over. So I'm going to say x squared minus 2x plus y squared equals 0. I didn't do anything weird. I just subtracted the 2x. Now I need you to go back to algebra 1 and tell me how I can fix this. I need it to look like that. I can't have it looking like that. Do you remember how to do that? I'm going to give you a clue. If I gave you this shape, what would you do to finish this shape? What would you do to finish this shape? And what shape is that? It's a square, and you just completed it. How am I going to fix that? Complete the square, right? How do you complete the square? Well, you have to add a number here. What number do you add there? You take half of this number and square it. What's half of -2? -1. And what's -1 squared? 1. Now, if I add something to the left side, what do I have to do? Add it to the right side. Now, do you remember from Algebra 1 what that turns into? Well, factor it. Well, how could you factor that? X minus 1 times x minus 1. And what's another way to write x minus 1 times x minus 1? X minus 1 squared. What you did was you built a perfect square trinomial. Remember that? Remember those words? You completed the square to build a perfect square trinomial, so it looks like this. Now, do we have to do anything to fix y squared, or is it just by itself and it's fine? It's fine. There is no number for it. So now I still have a circle, but tell me where the center is. It is at 1, 0. The 1 comes from here. There's a 0 because nothing's added to the y. So now this is a perfect answer, right? What's the radius of this circle? It's the square root of that number. I don't want to write just a 1 down because you might later look at this and think whatever number's there you write down, but you're writing the square root of that number. So indicate to yourself, you know, if it were 25, you'd be writing 5 down for the radius, right? So make sure you remember that this is r squared. So this is done. This is perfect and beautiful. And if you know it's a circle and you wanted to graph it, let's tie your geometry into that. Our center is at 1, 0, and our radius is 1. So if you're looking for concrete to tie that together, your radius is 1, your center's at 1, 0, and you have a little tiny circle there, like a little Cheerio. This part you may have forgotten on completing the square. It's very easy. You just take half of that number and square it. So it's always going to be adding a number because when you square it, it's positive. So no matter what that number is, if it had been 8, you'd say half of 8 is 4, 4 squared is 16, and you would add 16 to both sides. Not bad, right? So if you've forgotten some of that, if you have your notes and you wrote all this down, could you look at it and repeat a problem by yourself? There we go. So we are going to work on some homework. I'm going to do a couple problems with you,